Hi class, for this lab, we're going to do at least one example where we take a look at the chi-square table. We use the online calculator StatCrunch, and your main tool is going to be the actual chi-squared CDF command. So let's take a look at the lab. So here's the main problem. They want us to estimate, in this case, the p-value. So we're looking for a p-value. A test statistic is given and an actual claim. So n is equal to 11. That means that your degrees of freedom are going to be 10. So let me just write the claim here. And in this case, the values of sigma are greater to 17. Now, this is what it means. It means that the actual region, because of a claim greater than, it happens to be a right tail test. So we're looking at this sort of a region. Our critical value, in this case, it's going to be on the right. This specific value, it's given as 12.28. What we're finding is this portion here. The calculator doesn't have the actual shortcuts where you could just enter that you want to do in this case, a claim for sigma. So we would have to calculate the p-values manually. In this case, this area would be your p-value. And this is from the test statistic. Now, your main tool is going to be the calculator. So let me pull out the calculator. And this is the command. You're going to go to second. So you're going to go to second and distribution. Then you're going to activate the chi-square CDF. And let me go back to, let me put in the calculator on top. Okay. Now, your chi-square CDF, it's going to go from 12.28. So 12.28 to technically infinity. The chi-square distribution is unbounded above. So you would just say a very large value. And then the command is going to have degrees of freedom. So that would be the actual code. In this case, our p-value, and I'm going to round it to 4 decimal places, 0.2668. So 0.2668. And let me just write out that the p-value, it's approximately 0.2668, rounding to 4 decimal places. And this is using the actual chi-squared CDF. So once again, you're using lower bound, upper bound, and degrees of freedom. So the actual code, it's going to be the chi-squared CDF from 12.28 to a large value, and then 10, which represents the degrees of freedom. Now, that's pretty much it for all the problems that you're going to be doing the p-values. And let me show you how to estimate these p-values with the actual table. So if you look at the table, you're looking at 10 degrees of freedom and all the area to the right of 12.28. So this is going to give us a problem. So here you're looking at 10 degrees of freedom. The closest to 12.28, it's 15. So 12 is not in here. That would be the closest value. So if you use the table, you would basically be estimating that the p-value is 0.10. So it carries a ton of error, and we wouldn't really use the table because, well, you're not going to get a exact value. All of these would be estimates. So the table, we would rarely use it. On the good news, you guys have the calculator, so you don't have to worry about basically not having the code. There is a possibility that a homework assignment is using the table, and in that case they would have said the closest one would be 15.987 with a 0.10 of p-value. Now, I'm not going to write it because it's so off, but let me show you the chi-squared calculator. In this case, the only portion that needs to be changed is that 12.28. And then, well, actually here, I think I already run it. That would be your p-value. In this online software, you can actually see that it's already giving you the region that it's calculating. We're doing a right tail test, so that is already being displayed here. That's actually it for this calculator. You may use it for the homework assignments. Let me open up a StatCrunch file. So you're just gonna go to stats, then calculator. So stats calculator. So stats calculator, and then the chi-square distribution, and the area that we're running, it's above. So we also have 10 degrees of freedom, and the actual value is the 12.28, and here you see the 0.2668 that we found. So just different tools. For the remaining of the problem or the other problems on the lab, I'll just be using the calculator since I'm pretty sure that all the actual models of the TIs have the code. So we don't have the shortcut to evaluate it like we did with the mean, but we do have the shortcut. Well, not the shortcut, but a similar command to finding the area of z-scores, except that all of these are test statistics. And well, that would be the proper way to evaluate the actual p-value. That's actually it for this problem.